Here's my clock powered by an electrochemical cell. I've got a piece of copper wire and some aluminum. And if I stick that in the solution here, the clock begins to tick. Now, this reaction does not run very long, but nevertheless it shows that I'm producing an electric current that can be used to power a clock. My solution is some Drano. So I've taken some Drano. I used about 2 grams, a third of a teaspoon or so, and about 50 milliliters of water, and then dissolved the solution, and then put the aluminum and copper electrodes into the solution. Now, normally aluminum doesn't react very well, but under the basic conditions caused by the sodium hydroxide, the film that's on the aluminum comes off, which then allows the aluminum to react. And that sets up a potential difference and a flow of electrons. So the electrons are going from the aluminum through the clock and back into the solution through the copper wire. It's a neat little demonstration to show students the generation of an electric current using some dissimilar metals. Zinc and copper do not seem to work. Aluminum gives a slightly higher potential than the others. I use the alligator clips to connect to the battery terminals on the back of the clock, like this. It can go across like that, and that then replaces the battery in the clock mechanism. So to make the cell, I just took a length of copper wire and bent it into a couple of loops here, and then connected it to the edge of the glass by bending it over slightly, and then connecting the alligator clip to the copper end. I take the aluminum foil and just fold that a number of times, and we can fold it over here to increase the surface area, and then take the black alligator clip and stick it in the solution. And then we can measure the potential using the voltmeter, and we see that we get just over 1 volt, 1.1 volt or so.